Good morning, buenas. My name is Alex, and in this episode, we'll talk about Azure Unreal Pixel Streaming. It's a continuation of the previous episode. I would like to cover some areas of more detail. So first of all, let's look at the Unreal Pixel Streaming Azure Marketplace item. That's the reference implementation and deployment that we did in the previous episode. There are some common use cases outlined for this, including games, simulations, immersive experiences such as configuring a new car or walking through a virtual showroom. So I actually like the immersive experiences formulation myself a lot. Then we have the overview of Unreal Engine's pixel streaming with the same outline of common scenarios. Also in this document, there's a notion about auto-scaling and scaling from 2 to thousands of streams for some large deployments of Azure Pixel Streaming. And then also mention about architectures that we reviewed in the previous episode as well. Then I would also recommend watching this video by Microsoft team and Epic Games team on scaling Unreal Engine in Azure with Pixel Streaming and integrating Azure Digital Twins. Very nice video, just with Microsoft and Epic Games people talking about the specificity and how the solution was architected and organized. Then, notably, there's a deploying Unreal Engine pixel streaming documentation by on Unreal Engine website, also talking about those use cases and something that we discussed in the last episode. And then also very interesting is a hosting networking guide. So we'll stop here for a little while. So basically there are a couple of architectures in terms of how exactly you would like to organize your solution. So in this case, it's talking about using stun and turn servers. In this case, the multiple player endpoints, meaning that actually for some of the experiences, it's like a presentation when you have a presenter presenting content and multiple people connecting to the same stream. So that's kind of one way of deploying your experience. And that's the schema of that deployment. Alternatively, you may want, if your experience is more not shared by individual, then you'd like to deploy multiple full stacks with the matchmaking. And that's the deployment that we discussed in the previous episode. When we have a signaling server, we have an Unreal application running, and the matchmaker server is making connections through a dedicated signaling server to a dedicated instance of Unreal application. So that's just a refresher of how our architecture looks like. Then also in this document, it also describes some interesting features such as SFU, Selective Forwarding Unit. And this is just very helpful when you have different connections. Some connections are poor, some connections are great, and then basically through SFU you can actually serve and cater traffic appropriately. And at this time, SFU is an experimental feature of pixel streaming, and it's not being used by the Azure Marketplace item for deployment of Azure Pixel Streaming. But just notably, it's worth of noting here. Then also a little bit more details about the VM and the GPU specifically, and the consumption of GPU. So you can see that we're using the NV18A10V5 VM in our example. And also look at the GPU partitioning. So it's a half of GPU is being used here, while for like NV36 A10V5 it's using the full GPU. So it says GPU partition 1. So that's because of the virtualization technique that is applied for GPU partitioning, which means that one physical GPU can be used by multiple VMs. And there's an article on this, just again how you can maximize and accelerate graphics heavy workloads using NV ADS A10V5 Azure VMs powered with NVIDIA GPUs. So that's just an interesting kind of intro into our scenarios. So if we look at one of the deployments, and this is the deployment of one of the VMs with half of GPU used. So you can see inside of that VM, inside of the signaling server with Unreal Engine installed, like we have this VM, which is the NVIDIA A10 24Q. And you can see in the task manager as well as system configuration, you can see that it's been used. Yeah, now the question is, in the previous videos we described how you can have multiple signaling servers. So the question is, can you do more than 4? Because the maximum number of streams per VM is 4. So you can actually set up a 5th one. So I just copied essentially server 4 into server 5, just a plain copy, and then I basically change its config to specify the signaling server port, not 83 but 83 plus 1, 84, as well as the streamer port 8891 plus 1, which is 8892. And this way I was able to launch my Cirrus server with on port 84. And then obviously to make it work, you have to add a inbound rule for port 84. By default it's 80 through 83 for 4 ports, but if you want a 5th one, you could do it. And then if we look at 82, port 82, or port 84, so 84 is the 5th one that we enabling. It's gonna work, but for this to work, you also have to you also have to add a firewall rule for port 84, as we're showing here, and it will show up in allowed apps for that port. And once that configuration is done, then suddenly if you launch that Cirrus server signaling server on the VM, then the 5th one will be available. By default, the configuration gives you maximum 4, but that's just an illustration that just a configuration that by default it's giving you 4, and technically 5 and more are available. But again, in the previous videos we considered many factors that influence what exactly how many streams and how many users can be supported at the same time per VM. So 4 by default, and then if you want to customize, then potentially you can do more than 4, but obviously when you deploy it at scale, then 4 per VM will be your maximum. And this is how we did this with the 5. And then once we launch the Cirrus server, then on the 5th port, which is 84, you'll be able to launch your application and stream into web browser. Just an illustration, just to show how this is organized. Right. So each signaling server is a Node JS application, and this is just an example of one of the servers was launched manually, and one of them was activated through task scheduler on demand. So you can see the difference between how this is looking. All of those 4 different servers, they start at the system startup, and this is in task scheduler. So you can see how this is organized. So basically in actions, it launches PowerShell with just the start VMSS, and then the next parameter 4 in this case, it's the instance number. So for example, for the 4th server you have to specify 4, for the 1st server you specify 1, for the 2nd 2, for 3rd 3, and so on. And this is how this is done. That's a default configuration when you enable 4 streams per VM. And then if you want to add your own and have this launching at startup, similar idea. I just added one more, and I specified that the parameter for start VMSS PS1, the first parameter is 5. So that's the number of the instance number, which is 5, and then also set this up as a trigger at system startup. So if you already have your infrastructure deployed, and if you restart your VM skill set and VMs underneath it, then all of those signaling servers will start at the start of the system when you reboot, for example, your virtual machines. That's just how to set up a 5th and more beyond the maximum of 4. But again, as we said, 4 is the maximum that you get with the automated deployment, and this is just a quick illustration. If you look at the matchmaking server, and this is how its VM looks like, and then also you can see that it's basically launching the start MMS, and it's also part of task scheduler, and it starts at system startup. So this is just another again Node.js application that starts and runs matchmaking server. Just again illustrating how internally this is organized, and how when you deploy this infrastructure automatically through the marketplace item, how this is deployed. Now let's take a look at the multi-region deployment. So maximum number of regions is 4. In this case, we deploy it into 2, West US, West US 2, 4 streams per VM, and 1 VM per region. When we deploy it, you can see that there's a main resources that go into the resource group, and then two resource groups will be created by per region. So this is West US first and West US 2 the second. And then you can see that we have a VMSS, we have a matchmaking server for West US, and similar for West US 2, we have VMSS and the matchmaking server VM as well. The more regions you add, the more resource groups per region will be created. Now let's take a look at multi-region deployment. And in this case, we have 1 VM per region, 2 regions, and 4 streams per VM. So that means that we can have 4 individual streams and users connecting to those different streams. And if you launch them through Traffic Manager URL, or in this case, we're launching them directly through the VMSS URL and the public IP, then you can see that on the left hand side we accessing all of the West US streams, 4 streams from that VM that handles 4 streams in it, and the West US 2 right hand side also 4 streams in that VM. So we have 8 concurrent streams happening. And as you can see, as we play a little bit, you'll see that none of those streams overlap. So basically, each of those browsers displays a unique session for pixel streaming stream. So as we move around the world in one browser through one stream, it's not affecting any stream, because that's just again a dedicated signaling server is handling that communication, as well as the dedicated instance of Unreal that is running inside of that VM, handling multiple streams at the same time. Again, 4 maximum per VM. So the more VM you have, the more regions you have, the more concurrent sessions and individual sessions your users may have. And again, there's a distinction between a shared session when you connect to the same stream, and then you have a shared presentation or shared experience versus individual experience, and then you have to have independent streams and independent sessions going on. Also, this Azure Marketplace solution allows you to, as users disconnect, allows you to clean up those sessions. So new users connecting, they will be able to take advantage of a fresh session automatically as well. And then we also connecting through in this case from within VMs, just to show that from a local machine or from the remote machine, like for example, just kind of mimicking what might happen if you're connecting like two different people at the same time from different machines, from different IPs. So in this case, two instances and two streams inside of VMs. You can see that there's the one of the streams. It's the same stream. So when I'm basically moving in the world in the VM, then you can see that in the West US2 on one of the ports, on port 80, it's basically the same. We connected to the same stream, so you can see that when I'm moving on the right, it's moving in the middle. The rest of the streams are unique, and this is just to illustrate how overlapping connections and sessions, if you connect to the same stream, how this is looking. Now let's take a look at the dashboard. So dashboard is an important feature that allows you to handle large deployments. So when you deploy this dashboard, it gets deployed as an app, web app, and then it's a very simple React web app. And then you have to specify in the associated app registration, you have to specify this callback in this form. And then when you basically launch in that dashboard with the app registration created, you can see that I connected to multiple streams at the same time on different ports. And then it shows me pixel streaming dashboard. It shows 8 total streams across 2 VMs, 1 VM per region, West US, West US2. And then 4 sessions were connected and the 4 streams were available. That means again that 4 maximum streams per VM, and the math works exactly as we expected. And then if I'm connected somewhere else, so for example, I have another session on port 80, then as soon as that session disconnects and I close the browser, then I can connect on that port in another browser. So basically how I can pick up that session that just got released.